All right, welcome back. We're going to be discussing example 2, but before we do that, let's go over some vocabulary. Literal equation, that should be a new term for you. A literal equation, what is that? Well, a literal equation is an equation with two or more variables. A literal equation is an equation with two or more variables. So that's what we're going to be working with. Everything that we've talked about so far has just had one variable in the previous examples, but now we're going to be dealing with more than one variable. So example 2 states, solve each literal equation for a variable and then check your answers. So A, here we are, and I'm going to highlight that piece that we're going to check our answers. All right, so A says m minus n equals 5 for m. Okay, we're going to isolate. We're going to get m by itself. So to do that, we need to get rid of this negative n. We're going to do so through inverse operations, which would be to, yes, add n to both sides. So what we end up with is m equals 5 plus n. And m is isolated. That's our answer. And now we're going to check it. So I'm going to write the word check. Okay, we're going to write the original equation. M minus n equals 5. Okay, then what we're going to do is we're going to substitute what m equals. So right here, m equals 5 plus n. So instead of writing m, I'm going to write what m equals, 5 plus n. So I'm going to substitute in here. So 5 plus n minus n equals 5. All right, now we're just going to simplify. What is n minus n? Well, it's 0. They cancel each other out. And what are we left with? 5 equals 5, which is a true statement, which means our solution is the solution to the original equation. That is what m equals. Perfect. Okay, let's go ahead and work on B. B says m divided by k equals x, and we're going to solve this for k right here. Now, the number one thing you have to know is that whenever you're solving for a variable, you can never figure out what it is when it's on the bottom. So the first thing is we have to get that k off of the bottom, and there's a little trick in order to do that. Okay. How we get k off the bottom is by multiplying by k. Right now it's divided by k, so we're really doing the inverse operation. Now look and see what happens. We do it to both sides. Now this becomes k over 1, right? We're multiplying fractions. We look to cross cancel. Is there a common factor? Yes, k. K goes into k one time, k goes into k one time. We multiply across. 1 times m is m on the bottom. 1 times 1 is 1. M over 1 is just m. And then what we have over here is xk. Well, now k is on the top, and we can isolate it when it's on the top. We just can't isolate it what's on the bottom of the fraction. So that's a really cool little trick. Whenever you're solving for a variable and it's on the bottom, the first thing you have to do is get it off of the bottom, and how you do that is just by multiplying both sides by k. You see how we did that? It canceled out. Boom. Now it's on the top exactly where we want it. Now we're just going to go ahead and isolate k by using inverse operations. So right now, what's around k? X. How is x related to k? Well, this means x times k. It's being multiplied. So we're going to do the inverse operation of multiplication, which would be division. We're going to divide both sides by x. So we end up with m divided by x equals k. And then I'm just going to use symmetric property of equality. And boom, there we have it. There's our answer. But we're not done. We are going to check it. So I'm going to write the word check. I'm going to write this original equation, m divided by k equals x. And then I'm going to substitute this in right here, this fraction, in for k. So I have m divided by m over x equals x. And now we have a complex fraction, but that's okay. We're just going to write this differently. We're going to write it as m divided by m over x, because this means the same thing, all right? Now we can just change this to a multiplication problem. Whenever you're dividing by fractions, first thing you do is change it to a multiplication problem. And how do you do that? By multiplying by the reciprocal. So we're just going to flip that, and we get x over m. I'm just going to rewrite that equals x. And then now we're multiplying fractions. I'm going to make m a fraction, m over 1. And we look to cross cancel, and then we multiply across. So let's look. Are there any common factors between 1 and x? Well, it has a 1, so we can't really do anything with that. What about m and m? Do they have a common factor? Yes, m. M is the common factor between m and m. M goes into m one time, and m goes into m one time. And then we multiply across. 1 times x is x. And on the bottom, 1 times 1 is 1, so it'd be over 1. It'd be x over 1, which is just the same thing as x. So we have x equals x, which is a true statement, which means our solution is the solution to the original equation right there. All right, pretty cool. Let's go ahead and try a couple more. So C, it says 5 minus b equals 2t, and we're going to solve it for t. Okay. So we're going to try to get t by itself. Well, the only thing around t is this 2. Well, how's the 2 related? It's multiplied. 2t is the same thing as 2 times t. So we're going to do the inverse operation of multiplication, which would be division. So we're going to divide both sides, and I'm going to I got to divide this whole thing by 2. So what I end up with is 5 minus b all over 2 equals t. And then we're going to go ahead and use the symmetric property of equality and just flip the, flip it. 5 minus b all over 2, and that's our answer. And then guess what we're going to do? Yep, you guessed it. We're going to check it. So we're going to write the word check. We're going to write that original equation. 5 minus b equals 2t. And then we're going to substitute. T is equal to 5 minus b all over 2. So this goes in for t right there. So 2 times 5 minus b all over 2. Okay? We can't really do anything. We can't combine like terms, so we're just going to rewrite this. 5 minus b. But what we can do on this side is we can make this 2 into a fraction, and we can look to cross cancel. Well, here we can't cross cancel here, but we can with these 2's. 2 goes into 2. They have a common factor of 2, right? 2 goes into 2 one time. 2 goes into 2 one time. Then we multiply across. 1 times the quantity 5 minus b is just going to be 5 minus b all over 1 times 1, which is 1, and 5 minus b over 1 is just the same thing as 5 minus b. So there you have it. This is a true statement. 5 minus b is the same thing as 5 minus b. Therefore, our solution is the solution to the original equation. Perfect, perfect. Okay, let's go over here to D. All right. D says D equals m divided by v for v. So we're solving this literal equation, right? A literal equation is an equation that has more than one variable. And how many does this have? This has 1, 2, 3. So yes, this is definitely a literal equation. And we're going to solve it for v. Do you remember what the first thing we have to do with this problem is? Right, whenever we're solving, we can never have v on the bottom. So the first thing we have to do is get v on the top. Does anybody remember how to do that? I'm just going to rewrite it here. Does anybody remember how to get v on the top when it's on the bottom? Well, we just do the inverse operation. Right now it's being divided by v, so we're going to do the inverse operation of division, which will be multiplication to both sides. And even though these v's, they have a common factor, v goes into v one time, v goes into v one time, and they end up canceling out because we multiplied by v on this side and we multiplied by v on this side. V is now on the top exactly where we want it. So that little trick worked. This is just m times 1 is m. And now we're trying to get v by itself, so we got to get rid of this d. Well, how is the d related to v? It's related through multiplication, so we're going to do the inverse operation of multiplication, which would be division to both sides. D divided by D is 1. 1 times V is just V. Woohoo! We have V by itself. V is equal to M divided by D. Now we're just going to go ahead and check it. So we're going to go ahead and write that original equation. D equals M over V. And then we're going to substitute what V equals in right there. So V is the same thing as M divided by D, so we're going to substitute that in there for V. So we have D equals M divided by M divided by D. And this is a complex fraction, but it's okay. What we're going to do, even though it looks a little intimidating, we're just going to rewrite it, and we're going to go old school with it. We're going to say M divided by, old school division, M over D. All right, now we're just dividing by fractions, and whenever you're dividing by fractions, what you need to do is change it to a multiplication problem by multiplying by the reciprocal. So we have D is equal to M times, and we're going to multiply by the reciprocal, so we flip it, D over M. Then we just simplify this, so M, we're going to make this M over 1. We look to cross cancel, right? We can't do anything with the 1 and the D, but does M and M have a common factor? Yes, it does. M goes into M one time, and M goes into M one time, and then we multiply across. We have D over here on this side, and then 1 times D is just D. Over 1 times 1 is just 1, and D over 1 is the same thing as D. So this is true, which means our solution right here is the solution to this literal equation. Perfect, perfect. All right, let's go ahead and do a couple more. This one right here, x plus y equals 15 for x, and f, pq equals x for q. I want you to try E and F on your own. Try to solve this one for x, try to solve this one for q, and then check your answers, and remember to write that original equation. So now it's time to pause, okay, your device, work out those problems, make sure you do the checks, write in pencil, and then when you get done, press play and listen to the explanation, and if I do something differently than you, remember to erase and fix it. All right, I'll see you in a bit. All right, we're back. Let's go ahead. E, let's see how you did. X plus y equals 15 for x. So where's my variable? My variable is right here. So I need to isolate it. I need to get it by itself. In order to do that, I'm going to do the inverse operations. Okay, what's around y? The inverse operation of y would be to subtract by y to both sides. And what we're left with is x equals 15 minus y. And that's our answer. Were you able to get that? If you did, awesome job. Okay, let's see how you did on the check. If you didn't, go ahead and change your work so your work is the same as this. Let's go ahead and check it. We're going to go ahead and write that original equation. And then we substitute this in for x because it's the same thing. So 15 minus y is equal to x, so I substitute that in. Then we write plus y equals 15. And then we have negative y plus y. That's going to cancel out, and what we're left with is 15 equals 15, which is a true statement, which means our solution is the solution to the original equation. Okay, if you got that right, the answer and the check, that is amazing. Great job. Let's see how you did on F. So F says PQ equals X. We're solving for Q. We got to get Q by itself. Well, Q is on the top, so that's good. We can just start solving. Remember, if it was in the denominator, we would have to get Q on top first, but it's in the numerator. It's in the top part of a fraction, and you might think, oh, well, there's no fraction, but if I went and divided by 1, boom, then it would be a fraction. So we're good here. We just need to isolate this variable. Well, what is around? P. How is P related to Q? Through multiplication. So we're going to do the inverse operation of multiplication, which would be to divide by P to both sides. P divided by P is 1. 1 times Q is Q. So we did it. We got Q by itself. So Q is equal to X over P. Then we're going to check it. We're going to write that original equation. PQ equals X. And then we're going to substitute this X over P in for Q because that's what Q equals. Instead of writing Q, I write X over P is equal to X. And then I'm going to make P a fraction, P over 1. And then I just have a multiplying fractions, right? We look to cross cancel first. Can't do anything with that 1 and X, but what about the P and the P? Is there a common factor? Yes, P. P goes into P one time, P goes into P one time. Then we multiply across. We get 1 times X, which is X. And then 1 times 1 on the bottom, which is just divided by 1, which is just the same thing as X. So we have X equals X, which is a true statement, which means our solution is a solution to this literal equation. Perfect. All right, let's go ahead and try G and H. Okay, so for G, you're solving for J, and you're going to have to remember something with this one, and then for H, you're going to solve for X. So it is time. Please pause your device. Pause, 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 and then work it out and make sure you check your answers, and then when you get done, press play, and we'll go over it. All right, see you in a bit. All right, we're back. We're doing G, and we're going to solve for J here. So we have to isolate J. But the thing about J is on the bottom of a fraction. We cannot isolate it when it's on the bottom. So we have to get it to the top first. And how we do that is by doing the inverse operation of dividing by J. Means we're going to multiply this whole thing by J. We're going to multiply this all by J. All right. We get J over 1, and then we look to cross cancel because we're basically multiplying by fractions. So there's a 1 there, so you can't do a whole lot. But what about this J and J? Well, yeah, J is the common factor. J goes into J one time, J goes into J one time, then we multiply across, and we get N minus 4 is equal to KJ. We're still trying to get J by itself, but now it's on the top, so we can. Well, what's around J? K is. How is K related to J? Well, KJ is the same thing as K times J, so we're going to do the inverse operation of multiplication, which is division. So we're going to divide both sides by K, and what we end up with is N minus 4K equals J, because K divided by K is 1. 1 times J is J. But I'm going to use that symmetric property of equality and get this variable on the left side. And there we have it. That is our answer. But we are not done. We're going to check it. So let's go ahead and check. We're going to rewrite that original equation. N minus 4 all over J equals K. All right. Now, instead of writing J, we're going to substitute what J equals in there. So I'm rewriting the top, N minus 4 all over what J equals, and J equals this. N minus 4 divided by K equals K. All right. And then we have another complex fraction, but that's okay. We're just going to rewrite it. N minus 4 divided by, old school, N minus 4 all over K. And whenever we're dividing by fractions, the first thing we do is change it to a multiplication problem by multiplying by the reciprocal. So I rewrite the N minus 4 times, and then multiply by the reciprocal. K over N minus 4 equals K. I'm going to make this into a fraction by just putting it over 1. And what we do is we look to cross cancel first. Well, we can't do anything with the 1 and the K. Anytime there's a 1, you can't simplify 1 any further. But what about the N minus 4 and the N minus 4? Yeah, those are completely the same. They share a common factor of N minus 4. So N minus 4 goes into N minus 4 one time, and N minus 4 goes into N minus 4 one time. And then we multiply across. 1 times K is K, and on the bottom, 1 times 1 is 1. K over 1 is just the same thing as k. So we have k equals k, which is a true statement, which means our solution is the solution to the literal equation that we started with. Man, that was a tough check. Did you guys get that right? That was a tough one. I hope you did. If not, just go ahead and erase and rewrite. Okay, let's move on to h. Now for h, we're solving this literal equation because there's 2 for x. Now this, for the people that have done lines before, this is actually in a particular, there's a particular name for this. Well, actually, no, my bad, there's not. But this skill that we're working on with literal equations is going to set us up when we have to start solving for variables in lines, which is going to happen in chapter 4. So we're going to solve this for x. X is right there. Okay. So we just need to get rid of everything on this side. So first we need to start by getting rid of that 9 and doing the inverse operation. The 9 is positive. There's nothing here. That means it's positive. So the inverse operation would be to subtract 9 to both sides. We're left with 3x equals 2y minus 9. Then we're trying to get x by itself. We have x multiplied by 3. So we're going to do the inverse operation of multiplication, which would be division. We're going to divide both sides by 3 here. 3 divided by 3 is 1. 1 times x is x equals 2y minus 9 all over 3. And there you have it. Boom. That's our answer. We solved it for x. Now we're going to check our answer. We're going to write the word check. We're going to write that original equation, 9 plus 3x equals 2y. And then we're going to substitute all of this in for x. So 9, I'm going to write a line here. 9 plus 3, and there's multiple things here, so we have to put parentheses. Multiplied by the quantity 2y minus 9 all over 3 equals 2y. Now what I'm going to do is I'm going to make this 3 into a fraction. I'm going to make it 3 over 1. And then we're just multiplying fractions here, okay? So I have to simplify this side of the equation. So whenever you're multiplying by fractions, first you look to cross cancel and then multiply across, right? So here, is there a common factor between 1 and 2y minus 9? Well, no, you can't have a common factor when it's 1. I mean, the common factor would be 1, but that doesn't simplify anything. Everything just stays the same. So let's look here. Is there a common factor between 3 and 3? Yes, 3. 3 goes into 3 one time. 3 goes into 3 one time. Then we, I'm going to rewrite this 9 plus. Multiply across, which would just be 1 times that, which is just 2y minus 9. And then on the bottom, we'd have 1 times 1, which is just all of this over 1, which is just the same. So we're not going to write that. We'll just leave it like this. Then we're going to simplify this side of the equation. We have by combining like terms. We have these numbers. 9 minus 9 is, yes, they cancel each other out. It becomes 0. And what we're left with is 2y equals 2y, which is a true statement. We just leave it just like that. This means that our solution is a solution to the original equation. So if you got that right and you got the check, you're going to get my shot. You did a great job. If not, go ahead and erase and rewrite so that your notes look exactly like mine. All right, great job, and we'll see you in a little bit for example 3.